let me introduce to you our panel of presenters. Leading our discussions today is Dr. David Cahoon, pharmacologist, University College London. Also on our discussion panel is Dr. Cassidy Sugimoto, who is Associate Professor of Informatics, Indiana University, Bloomington. And wrapping up our program will be Ann Bainan, Manager, Solution Specialist, North America with Clarivate Analytics, formerly known as Thomson. Okay, David, we're going to start with you.
Okay, can you see my screen okay? Why metric corrupt science? So, my interest in this really started, well, any scientist is interested in it. It was honed by reading John Ioannidis' famous paper, Why Most Published Research Findings Are False, which, like most people, I thought at first was something of an exaggeration, though I think now it's not an exaggeration, actually. And part of the reason for this is because of metrics, I think. They simply don't work. They don't do what's claimed for them. There isn't the slightest reason to think that any metric measures the quality of papers. That's the main point I want to make. Bibliometricians look only at correlations. They never take into account what actually matters, which is the quality of the work. So I'll take a quick look at the following things: impact factors, citation counting, the H-index, and last and worst of all, metrics. In 2003, I had a little thing in Nature, at the invitation actually of Philip Maddox, the editor, who's quite sensible about these things. And it was called Challenging the Tyranny of Impact Factors. This histogram shows the distribution of the number of citations over 5 years for 500 biomedical papers published in Nature. And you can see that it's an exceedingly skewed distribution. Oops. The peak is a very, very small number of citations, but it goes up to 2,250 or more. Can't quite see how many it is, 2,300. And what that means is that the high impact factor of journals like Nature is not a general phenomenon. It's just due to a handful of very highly cited papers, like the first sequencing of the genome, for example. Of 858 papers published in Nature, the 80 most cited papers, 16% of all papers, accounted for half of all the citations. So for a start, the impact factor is statistically innumerate. I mean, it's just silly because it uses the mean number of citations, which is a completely inappropriate way of expressing the central tendency of such a highly skewed distribution. The mean's 114 there, but the median's only 65. The median's a bit better, but it's still far from representing the distribution. In fact, you can't really represent that distribution with a single number. You ought to show the whole distribution, but nobody does. Because of the skewness, it means that 70% of papers have fewer citations than the mean. There's the number. One has 2,364 citations, but 35 papers have 10 or fewer citations. Being in Nature doesn't guarantee you get a lot of citations at all. A slightly technical point, the skewness of the distribution is 4.1, so it's far more skewed than an exponential distribution, which has a skewness of 2. A normal distribution has a skewness of 0, of course. So these things are still, to this day, abused, despite the fact that it's been known for 20 years that they don't correlate with anything useful. I came across a little while ago a really invidious use of these at Imperial College London. They calculated each year for each member of the Department of Medicine. It's not all the same. Other departments are much more sensible. But medicine appears to be particularly bad. It always strikes me as odd that the caring profession is quite the worst when it comes to sort of cruel hyper-competition. Anyway, these publication scores were calculated in the silliest possible way. The impact factor of the journal was divided by the number of authors, and they were given weights according to the author position. 5 for the first and the last, even though the last person often does very little. 3 for the second, 2 for the third author, and 1 for any other position. So if you happen to be have done some crucial part of the work, but you were in the penultimate position, I'd say, out of 5 authors, then you'd only get a fifth of what the first author got. The most important thing is that these don't correlate at all with citations. There's no correlation between the number of citations a paper gets and the impact factor of the journal in which it appears, and there's no correlation either with this silly publication score. And this has been known for many, many years. Siegelen in the 90s pointed out that there's no correlation between the number of citations that a paper gets and the impact factor of the journal in which it's published. Since the impact factors calculated from citations, you might expect there would be, but the correlation is entirely destroyed by the extreme skewness of this distribution, something which is lost on the sort of administrators who love to use these things because they don't understand much about statistics as a rule. At Imperial College, the people were told that the minimum benchmarks they're expected to reach to have sufficient papers in top-rated journals to ensure 4 publications in the research assessment exercise with an impact factor of at least 5 and no overlap with co-authors from Imperial. So we're told on the one hand that interdisciplinary research is desirable, but then you're penalized because you can't have co-authors from the same institution, because that means they couldn't submit it to this silly research assessment exercise too. It's really a no-win situation. And they're supposed to publish 3 papers per annum, including 1 in a prestigious journal with an impact factor of at least 5. Well, it's a good job it's not a mathematics department, because there isn't a single maths journal which has an impact factor as high as 5. And to publish 3 papers per annum, it takes no account of the sort of work. Probably the second most, I've done 2 things that I would regard in my life as reasonably important. The second one was published in 2008 as a full article in Nature, and that took 3 years to do. 3 papers per annum is in many fields at least, is a sign that you're not really doing anything very deep, in my view, not a sign, not anything to be proud of. There's one person in medicine at Imperial who was written to by his boss, a chap called Martin Wilkins. He sent him a letter. I am of the opinion that you are struggling to fulfill the metrics of a professorial post at Imperial College, which include maintaining established funding and a program of research with an attributable share of research spend of £200,000 a year, and you must now start to give serious consideration as to whether you're performing at the expected level of a professor at Imperial College London. This was a full professor, age 51, and he killed himself after that. It was a most shocking affair. I got hold of his last email and put it on my blog, and it's had about 250,000 views now. It's by far the most viewed thing on my blog. But this is the result of unthinking use of silly metrics. Mostly it just causes misery, but sometimes it kills people. There are other examples too of people committing suicide under this sort of pressure. So if we're not going to just do this sort of silly correlations that most bibliometricians do, what are we to do? Well, one way of approaching it is to look at people who have universal respect, and another way to do it is to look at oneself. These are my top, one, two, three, four, five, 7 or 8 citations from Google Scholar. I don't use Scopus or Web of Science because they miss out half the important things. They're pretty useless, even, and they charge money for them, whereas this is free. Now let's just look at these 7 things. Only 2 of them have more than 1,000 citations. First one is a chapter in a book, so that doesn't even count according to most of the commercial databases. It was a long review of methods with some original content. The second one was done, it's got rather a lot of authors by my standards, usually I have 2 or 3, but I played rather a small part in this particular paper. In fact, I feel slightly guilty about having my name on it at all, and so I wouldn't rate that one very much. Third one is also a book, so that doesn't count either, with 942 citations. Another one in which I had a rather small role, and what's worse, the result is quite possibly a wrong one, but it was in Nature. So far, the citations are not doing very well. Then there's a review in the British Journal of Pharmacology, rather low impact factor. It was a review which was quite well received. It didn't have much original content. I thought it was stuff that people ought already to know, but apparently they don't. So now at number 7, we come to the first good paper. I think this is one of the 2 that I'm fairly proud of, if any one that's been nominated as a classic paper. It's published in the Journal of Physiology with a very modest impact factor, but it's the same journal that Hodgkin and Huxley published their classical work on the action potential in. It's a very good journal, in fact. And another one that rang a bell was actually the result of a 3-month trivial summer job between me, Erwin Nair, Chuck Stevens and Harold Reuter. They're very well-known names, and we happened to come across the first example of a particular sort of channel, very crude analysis, not much of a paper really, but because it was the first of its sort, it got a vast number of citations. And I've published things in Nature which have had only 57 citations. That's by no means the lowest for Nature. There's quite a lot with less than 10. But I've also published things in Philosophical Transactions of the Royal Society, which had an impact factor of 3 the last time I looked, with more than 600 citations. There really is no correlation whatsoever. Here's another little problem. In 1975, I had a summer in Seattle, which was great fun, but the paper, we turned it into a letter in Nature, which has 72 citations. It subsequently turned out that it was wrong. In 1981, in London, we revised it and published the proper one, which has not much more than half the number of citations of the first one. The one sure way to get something into Nature is to have something in Nature already which turns out to be wrong, then they'll publish the correction. Not the best way, but it's the surest way. And I've already mentioned that one. So now, let's just look at somebody right at the top of their field. I mean, if you're not in the same field as me, you probably won't know the name. But Bert Sackmann and Erwin Nair, two Germans who worked in the Max Planck Institute in Göttingen initially, got the Nobel Prize for invention of a method called the patch clamp, which allowed the first observations to be made of currents through single ion channel molecules. It was a huge breakthrough. And furthermore, they then developed it a few years later into a method which is far more useful than just observing single ion channels. It's actually quite noteworthy that Nair and Sackmann did the work themselves, not through postdocs. That's been true of the 4 Nobel Prize winners I know quite well. Consider what would have happened if Sackmann had worked at Imperial College London rather than the Max Planck Institute, he would have been fired. So just it seems a reasonable thing to look at the decade in which he got that led up to the Nobel Prize. 1976, they published their first short letter in Nature showing the first ever current through a single ion channel in a biological membrane. And at the end of that decade, 1985, they published a long 50-odd page paper with me, in fact, it was one that got nominated as a classic. Now, in that decade, Sackmann failed to achieve Imperial College's publication score, publication criteria, in 6 of those 10 years. The failed years included 1976, when his first letter was published that subsequently led up to the Nobel Prize. And he also failed in 1985 when the classic paper was published. In 2 of those 10 years, he had no publications at all. Never mind 3 a year, he had none at all in 2 of them. In 1981, they published a methods paper, which now, it must be over 20,000 citations now, but it was published in Pfluger's Archive, which is now called the European Journal of Physiology, which had an impact factor of 1.3 or something at the time, I think. It really makes a complete nonsense of impact factors and of citations. So if you use these sort of criteria used in Imperial, Sackmann would have been fired, so would Peter Higgs of boson fame, and less importantly, so would I. I think the message one can take home from this is, this is actually a quotation from a computer science site, but it applies pretty universally. Creation is sloppery, discovery is messy, exploration is dangerous. What's a manager to do? The answer in general is to encourage curiosity and accept failure, lots of failure. But this is not something that managers understand, and they don't accept failure. They expect you to be a genius every year. So what can we do about impact factors? They continue to be abused shockingly. One thing you can do is to sign the DORA agreement, the San Francisco Declaration on Research Assessment. It is deeply shocking to me that only 3 UK universities have actually signed this thing: Sussex, my own, UCL, and Manchester. In signing it, you undertake not to use journal-based metrics such as journal impact factors as a surrogate measure of the quality of individual research articles. Even the guy who invented them says that's wrong, but people do it anyway because they're lazy and because they're innumerate. And not to use them in hiring, promotion, or funding decisions. I might say that I have never used impact factors in hiring, promotion, or funding decisions. We simply ask people to send their 2 or 3 or 4 best papers, depending on their age. We read them very carefully, including the methods section in particular, and we ask them questions about the methods, especially when we're interviewing them. And it's just amazing how many people know damn all about what they've nominated as actually best papers. That's the way to do it. It doesn't matter a damn where they're published. Of course, it's never actually mattered less where a paper is published, because people don't find things by going to the library and reading a journal now. They find them with Google. It could be published anywhere. It could even be on an unrefereed blog or archive. It simply doesn't matter anymore. Yet, because of the hyper-competitiveness that's developed in science, instead of these surrogate measures being used less, they're actually being used more. And partly, that, of course, that's commercial pressure. People like Webber's Science, Thomson Reuters, hi to the last speaker, sell them and they make money from them, and that makes it easy for lazy senior scientists or lazy administrators to use them as a surrogate, and the result of that is to corrupt science, not to help it at all. In fact, I was rather shocked to see that UCL's current promotion form, despite the fact that we've signed DORA, still includes a comment which has been there for years: candidates may wish to provide impact factors, citation rates, or other bibliometric information. That's going to be removed, I'm told, very soon, so I should hope. In pursuit, now to a bit about altmetrics. In pursuit of why so much published research is wrong, I got interested in statistics, in particular the interpretation of p-values. Well, my work on ion channels has been very statistical, but it didn't involve tests of significance. So I did a few calculations, turned them into a little review, which got published in a journal called Royal Society Open Science, largely because it's free to publish in and free to read, and it gets some subsidy from the Royal Society. And it was, I think it was in its first volume. It was certainly too young to have any impact factor at all. After I got through the technical bit of this paper, there was a bit of a rant at the end, which said the misassessment of individuals by silly bibliometric methods has contributed to this harm, that is to say, the publication of a lot of false positive results. And of all the proposed methods, altmetrics is demonstrably the most idiotic. So I was quite amused to see that a year later, when the altmetric top 100 was published, I was in at number 33. And that, and the paper, in fact, has been remarkably widely read, far more widely read than anything that I've written about single ion channels. It's coming up to 150,000 full text views and 23,000 PDF downloads. It got a big spurt just recently when I published a popular version of it in Eon magazine. Of course, none of these things measure its quality. It was trivial stuff. It had been it was really all in Harold Jeffreys' 1939 book on the theory of probability. The reason for its popularity is A, because I have nothing better to do in my semi-retirement than play on Twitter, and but most of all because it's a topic of wide interest. If one looks at the citations, I think it's the most cited paper in that first volume of Royal Society Open Science. And they come from all over the place, everything from physics to the migration of Atlantic salmon, because it's of interest to anybody who does tests of significance. That doesn't mean it's good, it just means there's a big audience for it. I've written far better papers in single channel theory, but they're difficult papers. They're full of matrix algebra. Not many people understand matrix algebra, so it doesn't get any citations. Well, actually, some of them have quite a surprising number of citations, a few hundred, but I don't think people have read them. They just cite them. That's another little problem of the age. This is an example that struck me when I was writing about this stuff. Science magazine put out a tweet: non-invasive stimulation of the brain can improve memories. Now, anything with memory in the title tends to get a lot of retweets. Most of the people who retweet it won't have read it because it was in Science behind the paywall, so you could only read it if you were in the university. These are the altmetrics things, 375. It's quite it hadn't been out long, so that's quite a good altmetric score. 19 news outlets tweeted by 255, 7 Facebook pages. But if you actually read the paper, which of course I did quickly, you found that the paper wasn't about memory at all. It was actually about an fMRI study, the new phrenology. It's a subject which has been beset with problems of false positives. Memory, in fact, was only mentioned as one subsection of Figure 1. That's the picture, memory performance on the left. It wasn't done properly as a parallel study. It was a before and after study, a much more reliable sort of thing. And you can see that the difference between the sham and the stimulation has a single asterisk against it. Well, if you read the Royal Society Open Science paper, you'll realize that that actually doesn't mean you've made a discovery. It means there's at least a 50-50 chance that it's a false discovery. And Interestingly enough, the same issue of science had a note saying, with help from the American Statistical Association, science has established a statistical board of reviewing editors to provide better oversight of the interpretation of observational data. Well, this was an experiment, so they didn't get a look at it, evidently not. So, conclusions. Impact factor have been shown not to measure quality, not to measure anything of interest for 20 years, at least. They're simply statistically illiterate. Anybody who cites them to you should be shunned because they don't understand what they're talking about. Citation counts don't measure quality. They depend largely on the size of the audience and the easiness of the topic. The more mathematics you have in, the fewer citations. That's a very reliable observation. So altmetrics appeal to the innumerate, those who can't read or judge for themselves. The H-index is absurd because it depends on the age of the person. You want to give somebody merit simply for being old, but that's what the H-index does. Altmetrics, well, it's just a measure of how much time you spend on social media rather than doing research, and how much ingenuity you can muster in including words like sex, memory, or penis in the title. They all get very heavily retweeted, things that's what's in the title, and I should think the altmetric score could very well be negatively correlated with real quality. I don't know about that, but I can imagine it's so. All metrics encourage short-term performance. They encourage corner cutting, and they encourage outright dishonesty, fraud. They contribute to the crisis in reproducibility that's engulfed science, and which has now become very serious because the public are onto it. And every time I criticize some alternative nonsense like homeopathy, they say, but look at all the false stuff that's published in real science journals. And the trouble is they're right. They're not right about the homeopathy, but they're right about the state of hyper-competitiveness of science having caused real problems that are encouraged by trying to measure things with metrics rather than reading them. And their use means that jobs go to dishonest spiff scientists, not the good ones who make great discoveries in the long run. They're simply a way to make money for legacy publishers, I think. We'd be better off without the metrics. In fact, we'd be better off without the legacy publishers, because they both corrupt science. What we should be doing is publishing everything on archive sites, leaving the comments open for post-publication peer review, which shouldn't cost more than $100 or so per paper. Okay, so my time is up. I better stop there.
Thank you. I do have a question from the audience. Someone asked, do you have an opinion on why schools, funders, and the like rely on metrics as a criteria for promotions, funding, or other such uses?
Because they're lazy and they haven't got time, or maybe haven't got the expertise to read the paper, which is the only way to judge the worth of a paper is to read the damn thing. And of course, that means you have to know about it. You can get somebody else to read it for you. But it's laziness and innumeracy. As I said, it's quite easy for jobs. We have never, ever used them for job applicants. You can use a method like that I outlined, which is far more likely to get the right person. The real problem is for grants, because there's no obvious way of escaping peer review for grants, and there is a tendency for grant committees to be as lazy as anybody else in actually reading the papers, and the way to save time is to use these surrogate outcomes that are so silly, but they have to be persuaded not to. They have to be persuaded not to before it ruins science. They are responsible for this crisis of reproducibility to a large extent. That person is understanding statistics. So I hope things will improve. There's quite a lot of pressure now. to do so, but it's a long way to go.
As a follow-up to that question, they also asked where specifically funding is concerned or even a promotion. Can you talk a little bit about the idea that an impact factor of a journal may or may not be tied to the quality of the individual article within that journal?
Well, that's been known at least since the 1990s. Per Seglin published a paper then showing that there was no correlation whatsoever between the number of citations that a paper gets and the impact factor of the journal in which it appears. It's astonishing, considering this is a knowledge that has been known for at least 20 years. It's astonishing how many people are unaware of that. But it's the case. Of course, citation itself is a dodgy measure of quality, as I've pointed out. But it really is astonishing that people just don't know that there's no correlation between those two things. It's been known for decades. People are, I guess, concentrating on their own research and just don't bother to find out the pertinent facts. But there's no excuse for not knowing that these days. Enough's been written about it, for heaven's sake.
We have another question, and it starts with a comment. The individual says, I agree with all of the criticism of existing metrics to assess research. What do you suggest is a good quantitative way to measure quality of research?
There's no quantitative way to do it. All you can do is read the paper. There's no possible other way. And having read the paper, you may still be uncertain. If you look at the first papers to do with lasers, you would never begin to guess how important they would be, or they'd be the basis for DVD players and all these sorts of things. It's often simply impossible, even if you know a lot about the topic and read the paper, to know how important it's going to be. You can judge its quality, the quality of the methods better. That doesn't mean it's going to be important, but at least it means it's likely to be right rather than yet another false positive. But there is no mechanical way to do it. It just doesn't exist. It's a real problem that people are very reluctant to say, I don't know. They pose a question, which is an interesting one, but they will never end up saying, I can't answer this question, which is often right. It's the same in medicine, Take non-specific low back pain. There's damn all you can do about it, or any chronic pain condition. There are chronic pain departments, but the thing they never mention is there's not much they can do for you. The first thing you should say, if you can't measure anything, is to say that I can't measure this. And you cannot measure the quality of a paper even by reading it, but reading it is the only thing that will work. There's no possible surrogate measure that I can think of, or that anybody else has thought of, that will do it for you.
And then I have another question. Someone asked, do you have an opinion as to why individuals have, or institutions have started to look at and measure alternate metrics? One, for example, the number of times somebody shared something on Facebook matter in science?
It doesn't matter for the science at all. It's good to engage the public. I have a blog now which has been reasonably widely read, and which I explain some statistical phenomena like why screening tests don't generally work, and queues for beds in hospitals, and also quite a lot about downright quackery. And that sort of engagement is good if you've got the time for it. I've only got the time for it because I'm semi-retired at 80. I couldn't have done it when I was doing full-time research. But it's a good thing when people can do it. It's just nothing to do with the quality of your research, that's all. It's not a sort of thing on what you should be judged for promotion, because it's got nothing to do with the quality of your research. It's a good public service for those who have time for it. But of course, universities like it because they think it helps their name. My posts don't always help my name, because sometimes I criticize my own university and I think they're doing something silly. But no, in general, public engagement is good, but it's nothing to do with quality.
And then finally, someone asked if you could just confirm that the citations you included earlier were from Google Scholar.
They were, yes, yes. The commercial ones don't even include books. They're useless. They cost money and they're useless. If you want to check whether and I've checked a few of the citations of mine in Google Scholar, and they mostly come from pretty respectable sources. If you're writing about something fairly esoteric like single ion channel kinetics, for example, that doesn't get referred to on blogs. And even so, reference from a blog may be relevant if it's a scientific blog. So, no, I think Google Scholar's excellent. A lot better than the ones you pay for, like Thomson Reuters. Sorry.
Okay. If we have any further questions from the main audience, I will send them to you separate if that's okay with you, so that we can now move on to our next presenter,